welcome everybody. We will be getting started in a minute, but please can I remind you to turn your microphones and cameras off. We will be recording this session, so please make sure that you keep them off throughout the session. If you do have questions as we're going along, feel free to pop them in the chat. When it comes to Q&A at the end, we'll go through the questions in the chat and put them to our speaker. We will give people another few seconds to get started, but bear with us. For those who have just joined, this is a reminder the session is going to be recorded, and so please make sure that you keep your microphones and cameras off throughout the session. The topic for this session is making data useful for flexibility services. We have an exciting speaker with us today. We have Sam Hinton, who is a senior data scientist at Arenco and loves all sorts of data science. I've been reliably informed that he loves Bayesian statistics, so that puts him in good company. And he's going to talk to us today about making data useful in flexibility services. If you have questions, please do drop them in the chat as we go. There will be time for Q&A at the end. So over to you, Sam.
All right, sounds good. Give me a second and I will share my screen. Let's see. Please let me know when something pops up. Teams is great in that okay, fantastic. So I guess, a super brief intro to who on earth I am. I'm not just a Bayesian statistician. I can't even say the word. My background is actually in quite a few things. So I come from academia. That's actually made down in the bottom left in Germany. Good old Germany, loved it. And I guess I come from originally a software developer in the financial services back in Australia, so back office and front office stock market trading for the ASX. I moved into physics where I did astrophysics, looking at various data pipelines, data processing from our telescopes and statistical models of dark energy and dark matter. And then I decided, what would be great, trying to do something that helps the planet, because let's be real here. What happens in a galaxy 10 billion light years away stays in the galaxy 10 billion light years away. So I thought I would try to dedicate some of my time to something that hopefully, makes a difference on the world. And I feel like that will resonate with a lot of people currently here. And I guess that led me to Arenco. And I've been working with them now for a while, setting up various data pipelines, data orchestration, and doing all of the fun forecasting, predicting, and optimization that comes with the company when we try to trade battery assets on as many possible markets in the UK as we can. So I guess the reason why originally Steve and I had a chat about what would be a useful topic for a webinar, and we came to, we've been working on a project that we'll release soonish, a report connecting academia and industry, but a very large part of what came out of the interviews and the papers that we read on that was just how critically important the role of data is, especially in this commitment that we have to try to get to net zero, not by 2050 or 2035, but as fast as humanly possible. And that's only going to happen if we do embrace this sort of data-centric thinking and all of the data that's at our fingertips. Well, really, that's the issue, isn't it? It's not quite at our fingertips right now. It's in various systems, locked behind various walls, and trying to get access to it and get it all looking the same is actually a massive challenge. That's exacerbated if you're not working in like a sort of a large company that has many bodies that can be thrown at a problem. So for those that are here sort of in an academic context who have been doing their own research, probably know the pains of trying to find sort of modern, reliable data to use in those research projects. Now, data is important for pretty much everything. So everything in green on the right there is uses data, and everything that's in even more green are things that are directly relevant towards this sort of data-centric approach to that build back greener policy that the government put out. So the fundamental problem that at least I've encountered, maybe I'm alone in this, but I feel like I'm not, is that we have concrete problems to solve in this industry. So for me, with Orenco, that's how can we most effectively utilize energy storage assets to try and, for our clients, make money, for us personally, turn off gas peakers and get them to use batteries instead. It's all about trying to decarbonize the grid. But to do that requires a lot of high quality data flowing into our systems very consistently, and finding high quality consistent data that you can trust is actually fairly challenging. You sort of get the left there, which is my representation of what it's like when you go to Google and type in, energy forecast UK. You get a whole bunch of sites, some of them with some ancient CSVs, maybe if you're lucky, some of them boasting fantastic APIs that you only have to pay £400,000 for to get access to, and then some that are apparently good APIs, but you can only use them under really weird license conditions before you have to sign up to an enterprise agreement. And it's difficult. Well, all we really want is the ability to press a button and download a pandas data frame or something similar to that. Now, let me just, I think someone is unmuted right now, but I do not have the power to press a mute button, so I'll leave that to someone else. Okay, so moving on from this problem, there's obviously a Band-Aid solution, which is you can get someone to do a lot of the heavy lifting in finding these data sources and then cleaning them up and then putting them on places like Kaggle. And I know that this is popular because I've read enough research papers that tend to use the same data sets to look at various different things. And like the reason for that is because there are certain data sets that are easy to get a hold of. And if you want other data sets, then you really have to start digging and start doing a lot of work yourself. I am at no point in this conversation going to provide sort of a silver bullet, like just do this and all your data problems will disappear. I wish I could. Instead, I guess the purpose of this talk is I'll run through the problems that we've faced and how we've tried to solve them. Some of these solutions, if you're already in industry, will look very similar to what you may have developed and deployed in each of your own companies. If you're an academic, this may seem like overkill, but if you're part of a research organization, these are things that, at least back when I was doing research, we started moving towards. There was sort of that greater shift towards needing high quality data in our research, to the point that when we got our grants, we actually put aside one of their postdoc positions for either a database person or a software engineer to come in for 6 months and set up some infrastructure. So the Band-Aid is great, but it doesn't always work. So I've broken down sort of the topics that I'll go into a bit more detail into connecting to these APIs. So where can you find this data, how you can actually get the data from the APIs, and then how we've been formatting and saving it out to try and make it as, I guess the title of the talk, as useful as possible. But what I mean by that is I don't want to have to think when I have data. I want it to be good enough and to just load it into a data frame with as little effort as possible so that I can use it in whatever way I actually want. So I'll run through each of these brief sections. And if anyone has questions about specific techniques, I won't go too deep into each option, but I can talk at least to the extent that I know of them at the end. Okay, so the very first point is connecting to public APIs. You have a few options here. The one that I think most people hope, at least the one that I can see myself hoping for, is that you get lucky and you thank Ayrton, who has given a webinar before. I think that's on YouTube now as well, but it was recorded, and he detailed a whole bunch of the work that he's done creating interfaces in a centralized location that you can see down here, this link, that provides wrappers to access data from National Grid, Elexon, Octopus, and there's quite a few other ones in there. So that would make your life nice and easy if you're in the Python ecosystem. Obviously, if you're coming from an R background, life is a little bit harder because you have to hope that someone has done this for you. And if someone hasn't done this, let's say that you have, for example, some data that you would like to download from Elexon, or like the BMRS is where we get a lot of our data from. If you don't have someone that's provided a wrapper, then, here's one of the examples of the documentation that Ayrton has provided. So he's put a lot of effort into this. So if anyone isn't familiar with this group, this collection of repositories, please head here and have a look at that if this sort of data source might be of use to you. If it's not, then you sort of have two options, which is you can forego a data wrapper, right? You can use Postman, or you can curl down data yourself if you only intend on ever doing this maybe once or maybe twice. If you intend on trying to sort of keep your data up to date, and by that I mean, let's say you ask for the latest data every settlement period in the UK, every half hour, or potentially every day or every week, then you probably want something that isn't just a curl pointing to a timestamped CSV. Not that we all haven't done something like that before. So you can either make your own wrapper. This, of course, has a high barrier to entry if you're coming from an academic background where you might be a bit apprehensive to write code, put it publicly in an open source environment, and then publish it as a package where everyone can come in and critique and then raise issues or bugs on it. That just means you have to now support this for the rest of your life. So it's not that attractive an option for a lot of people. But you can obviously make your own wrapper and keep it private. This is the approach that we've actually taken at Arenco. For each of the data sources that we connect to, we have our own code that wraps those data sources and provides, I guess, a transparent and consistent way of accessing each API, so that the details of what each API needs are hidden from our end user. So here's a modified bit of code that I took from a function I wrote many moons ago. This connects to the BMRS and downloads the dir-sys data report, which is the imbalance price report. So what we've done is privately, we have functions like this that take a standardized input, so a from date and a to date, and they return a standardized output. In this case, a good old pandas data frame. And you hide away all the complexity or the endpoint specific logic as to what the keys are called, what your download formats are, your API keys, all of that gets hidden away, such that we don't just have imbalance price, we have dozens upon dozens of these for more than just the Lexon, but they're all accessed the same way. And so that makes it really easy for us. If you want something else, you just ask for something else. You don't have to worry about, but what does this API actually need? Like, maybe the date format is different. Well, hopefully you've moved the logic away so that that's not front and center to the person that's needing the data. Now, if you're a sole researcher, this looks like a lot of work. Like, this is, well, it was, I modified it, it's no longer, but this is sort of like production level code that you probably don't need to do. So in this case, I know that there are people like Ayrton that are trying to organize, groups of people that want to contribute to open source software, and to try and divide up some of the burden. So for people that are interested in trying to make data access more consistent and more open, rather than just having an API somewhere that everyone has to hit themselves in their own way, there are definitely people that are interested in improving that for the energy system APIs. Okay, so I'm happy to touch more on that at the end, but on to the next part, which is scheduling ingestion. So the purpose of getting useful data is that you don't just get data for the year of 2021 and then that's it. You want the latest data as often as the latest data is available. So you could run something manually. You could do something like email yourself a reminder or put in a calendar event so that on Monday morning, every Monday, you download some data yourself and you upload it to Dropbox or Google Drive or an S3 bucket. That probably will get tiring fairly quickly. So you can take it one step further. You can automate it with cron jobs. That execute either a curl command directly if you just want to dump out the raw JSON or XML, and I'm going to talk about XML at the end in my pet peeves, so stay tuned for that. If you did want something a bit more, so a little bit more robust, you can use CI/CD for this. So what you'll notice is if you visit that collection of repositories that I pointed out before, the OSUKED one, you'll notice that there's a whole bunch of data that gets updated every day. And that's because Ayrton has set up via GitHub Actions a task that automatically will download data and then push it into a Git repository so that anyone can simply go to this repository and it will have the latest data in. They're just done as a bunch of CSV files, but at least no one has to manually come in and make sure that the latest data is there. You can just refresh the page and download the latest data with what you want. And if you want to go even further beyond that, if your use case is such that you're either a researcher in a large group that would benefit from having this data consistently available with sort of high reliability and not much delay between publication, then you can either do the heaviest duty thing. I haven't even put on here, which is you subscribe to a message service, you use something like RabbitMQ, and you say, I want the prices as soon as they're published, Alexon, and then Alexon sends you a message, and then you deal with that. But that's, I think, definitely outside the scope of what most people would want. So I thought I would put in just two little boxes here for Prefect and Airflow. So these are data orchestration tools. They're very popular for data engineering. Airflow, probably the most popular one these days. Airflow 2 has released in the past year, which was a great thing, and Prefect 2 is coming in the next quarter. So I'll run you through sort of how those work. For cron jobs, if people haven't seen them, all you really have to do is go to crontab.guru, figure out an expression that dictates when you want something to run, and then you can schedule that in a single line of code on Linux or Mac, and that's the end of it. That's all you need to do. Okay, so talking about Airflow and Prefect 1 both operate using DAGs. I apologize for the resolution of this image. I took it directly from Airflow's documentation, and apparently they like to shrink images as much as possible, which, fine, but come on. So the way that this works, the way that all DAGs work, so DAGs being directed acyclic graphs, is that you have effectively a list of tasks. The example that they give in their documentation is add one and then sum it. So you have some number, your task is to add one, and then your next task is to sum the numbers. It's a bit of a useless and trivial case, but what you can always do, and the way that we use it, we don't use Airflow, we use Prefect, which looks like this, is we might have something that says, download the data from Alexon. And then we might have a separate task. So a task just being a function, right? So one function that says download the data, the next function that says process the data, and then a third and final function that says save the data. Whether you save that data to an SQLite database or a Postgres database, you upload it to an S3 bucket, or you save it out to CSV, it doesn't really matter. The benefit of using a data orchestration tool is similar to cron. You can set up schedules for when they should execute. But if you do have tasks that rely on each other, for example, you can't save the data out. If you failed to download the data, you can put in caching and retrials so that you can say, look, if it stops working, wait 5 minutes and then try again. So you don't have to worry that the data won't be there in the morning. You can say, try a dozen times. Like if it takes a dozen times, then just do it. And that means that you're faced with less running around, let's say in the morning when you go to check, is your data actually there? Okay, so this is an example of one of our flows. I've cut it off so that you can't see everything, otherwise you wouldn't be able to read the text. But what this is us grabbing as much data as we possibly can for a given day. So this was run on the 5th of May. Maybe it was for the 5th of May, probably the 4th of May, I'm guessing. But you can see we're fetching the ETS half-hour price. So that is the price of the half-hourly ETS, the day-ahead auction, and then various other endpoints that Elexon or National Grid or other providers offer, like the generation per type. So that's broken down, solar, wind onshore, wind offshore, nuclear, oil, gas, etc. You get the idea. But we run all of these, each as a separate task, so that if one of them fails, we know what data might not be there, and then we know what needs to be rerun. Of course, we do have this to rerun a few times if it fails. So it doesn't happen often, but it can happen, and I'll rant about that at the end as well. Okay, so moving on to formatting the data. The top picture here is sort of what I think most of us like to work with our data in. So the data's in a wide format. Generally, in the energy industry, most of the data we deal with is time series data, whether those are forecasts for various weather patterns or the solar or expected demand, or most things are time series. What I would recommend to people too is don't store things and in this wide format. And I know there are a lot of cases I've seen where people will download data. They will then post-process the data. They will clean it up. They will do various things. Like if you're doing this in a machine learning context, potentially you might do some feature engineering. You might combine a few different columns to make something brand new, never before seen under the sun. And the idea here that I want to say is, great to do all of that, but never save that out. If you're going to save data out, save the raw data out for two reasons. One, generally, feature transformations or feature engineering is pretty quick to run. You can recreate those features and then you save out the code in a Git repository as to how you want those features engineered. Because at the end of the day, it's much easier to version code than it is to version data. As much as there are certain tools that will do data versioning, they're generally not as easy to use as someone that has a Git repository that has various commits with code in it. I think far more of us are familiar with how to use Git than we are familiar with how to use any of the handful of data versioning systems that are out there. So on that note, I would say save your data out as close to raw as possible, and then save your data in long format if you can. This was one of the first things that we did when I started going down the data pipelines internally, which is if you simply melt down your data frames like this, everything looks the same. You can now add different features, different variables, without having to, like if you're saving this to a database, your schema is very simple: a date, a label, and a value. You don't have to worry that, oh, I have a new data source. I need a new table in my need a new table in my database, or I need a new column in a particular table. That's just called my data. Instead, if you melt it down, you can add features without having any schema updates. And if you need extra ability to filter down on those, you can obviously do something like nested key value pairs. I know is fairly popular. So for example, you might have a country equals UK. And that's very easy to add in a schema if you end up going down the route where you want to save this out to a database. Now, if we start talking about databases, someone's probably going to ask, well, what about, like the proper solution? So data warehouses, or whether that's anything that's managed by Amazon, you have a little Snowflake here, or any of the others. There's quite a few managed data warehouse services now. If you need those, then you're probably already you're not going to get anything from this talk that you don't already know. But for a lot of circumstances, I would say that especially if you're an academic here, is probably far too much infrastructure engineering than what you need. I think what most people need, or at least what I personally needed back when I was doing research topics in time series data, wasn't oodles and oodles of cloud infrastructure. It was just the ability to get the last 3 months of data for certain columns, certain features, without having to jump through too many hoops and log into too many different services. That's really all I wanted in life, and I never got it. So in terms of saving data out, I'll run through these quite quickly. Obviously, CSV file dumps are tried and true. They're not the best in terms of scalability, but they work. Like, no one can deny that. You can do them on your local machine. You can schedule them up and then upload the CSVs into S3. If you want to make this up in the cloud, you can have a little Lambda function that you can say run every day and then download this, upload it to S3 here. If you're going that far, you probably need to jump into something like a database instead. You can run SQL Alchemy, and that's just a single file-based database that you can run and get set up in Python in about 3 seconds. If you need more than that, there's Postgres. And there's, on top of Postgres, you can put something called timescale, which is effectively Postgres on steroids, and it provides you a bunch of aggregation functions that are useful for time series data. But that's only if you, it's only really useful, I think, if you intend on doing any of your data analysis or aggregation via the SQL itself. If you're just planning on using the database to get data into some data frame, whether you're in Python or R, and then do your aggregation, a stock standard database is fine. You can then ask someone like Amazon to manage it for you. This is very useful if you don't have, or you don't particularly want, a large IT or infrastructure engineer department in your research group or your company. And then obviously above all of that are data warehouses, and they'll combine managed database systems with message systems and various other ways of storing and accessing data for different data formats. I'm not going to talk about those because, frankly, I no longer have good experience as to where the industry is headed with that and what the amazing time series updates have gone on in data warehouse land. Great, I've talked about all of these, so I'm just going to skip through all of the notes there. And so I guess I get asked this a lot actually, which is, why would I bother going to SQL when I have CSV? For most people, especially in research land, it's not that useful. And frankly, I guess I agree. A lot of the time it isn't that useful, but at some point you may run into issues with versioning various CSV files. If you have a managed database, it's very easy to just right-click and say, here's a checkpoint, and now you can come back to that at any point in the future. Now, one other thing that we ended up investing time that might be useful for other people is so once you have the data located somewhere, accessible through some method, whether it's your own wrapper to an external API, or maybe you've downloaded the data and you're storing it in a CSV file or a database, is we wrote some code. There are sort of off-the-shelf solutions that will try to do some things like this, but we wrote some code that, again, hides away that complexity of where's the data, how should I access it, and what format is the data in. So here you can see a snippet of our internal feature store where all one of our team members, data scientists or data analyst, wherever they sit within the company, can do to access data is just say, hey, I want a feature store. This is a Python project that is shared by everyone. And I mean shared as in like everyone pip installs it. It's installed on their systems. And then you can just say, hey, I want the latest features, and here's a list of features, and here's some dates. And it spits out a data frame. And the idea here is you don't need to know where the endpoints are. You don't even need to know where these features came from. That you can check. I'm not showing you the full detail that we have in this code here. But the idea is when we have an intern come in, or someone that we're collaborating with on a master's project, and they say, hey, I need some data for something. It's no longer the torturous, well, here are some like a PDF, like if anyone's seen like the BMRS API, it's a PDF that's like 200 pages long. You don't want to send that to a new starter or a master's student that's just trying to get started. Instead, we can say, here are these 2 lines of code. If you run them, you'll get a data frame that you can start doing some analysis on. You can start looking at your research project with this. And look, if that's all you need and that's all you want, take the data frame, you can save it to CSV and just load that in the future. But now they have the ability at any point to just say, look, I want the latest data again, or I want different features for a different time range. And they don't have to figure out what any of that means. Okay, so yeah, I guess I'm going through effectively things that I've already said. This is another one here that I've learned. If you store the data locally, you get around, and by locally, I mean, so long as you control it local, so maybe in a database up in the cloud somewhere, you don't have to worry about rate limits, which we've been hit with before, or how long it takes certain endpoints to respond. So I know that within Alexon, I know that especially with some of the BM data, you can be waiting 5 minutes for it to come back with a single BMU's data for a single day. Sometimes it just times out on you too. And so you get around all of this by having the data pulled down already, because you've done the heavy lifting already. Okay, so that's sort of a brief rundown of what we have done to solve some of the data issues that we have that allows us to access our data with very, very little fuss, and allows us to look at various research projects or speculative things very quickly. And now I get to rant about various pain points that still take my time when they shouldn't, or things that I feel like should be solved, but they're not. Okay, number 1, crappy documentation is everywhere in the energy industry. Most of that is because a lot of the data we want comes from regulatory bodies. Those regulatory bodies are 30 years behind the rest of the industry, and it seems like there's a much less of a focus on data transparency and data visibility within those organizations. So what I've shown you here is that imbalanced data that I showed you the function for before. And this is actually really, really good compared to the rest of the industry. It's not great because it's accessible within a PDF and you have to search for it. It's not great because it's missing certain key details. For example, if you end up finding this PDF and you go through it, you'll notice that it returns date times, and nowhere does it actually tell you whether those are London-based times or UTC times. So there's some ambiguity in what various data coming back actually means, and then it's difficult to follow up and try and figure out what does it mean. Like, who do you approach if you don't understand something in this document? Well, you go through 15 different help desks until you hopefully find someone that in 6 months' time can answer your question. So I said the previous one was great. Here's an example of one that isn't that great. So I remember getting access to this API after seeing this documentation. I was like, yeah, look, this is fine. The requests aren't covered in the documentation. It's like, yeah, I get it. Sometimes documentation is the last thing you build out, and it turns out it just hadn't been built out. There was no documentation because there was no endpoint. So we ended up, paying for a service that didn't exist. That's sort of like the least ideal way that we can do it. And then in terms of other offenders, I'm sure many of you are quite familiar with the way that National Grid will publish various data, which is, here's a website and it will have a list of CSVs and you can download the CSV that you want. And I was like, guys, I don't want to be scrounging up and determining CSV URLs to download that data. Like, let's just, like, it's 2022. Let's just have an endpoint here, a nice REST API, and get this data flowing. So on that note, Ayrton shouldn't have to fill the gaps that many of these, especially the regulatory bodies, have in that, Python and R, to name the two big players, represent, I think, the majority of both industry and definitely research uses for this data. And yet there's no API, there's no package that gets provided by these organizations that makes this easy. So people like Ayrton come in and they say, well, look here, I've written something, and now it's on them for the rest of their life or until someone else picks up the project to update to any changes in those APIs that often don't get communicated at all. So if you want a good example of this, Yahoo Finance, right? They have an API, but they also release a package that is easy enough to use that you don't need to go to their website to look up the documentation. You can just use their code. It's class-based and everything makes sense and it fetches the data it needs under the hood. On top of this, things that make people like Ayrton's life harder is the fact that a lot of the APIs follow these ancient standards. So all of the data that we get from Elexon and National Grid will come back as XML. So they're SOAP APIs. Which is fine, except that sometimes the XML is badly formatted and it doesn't quite work. And so you're left trying to figure out exactly what this data is meant to be. And at this point, REST APIs have been the de facto standard since I started sort of in software finance in 2010. So like, there's been time. If we could move towards these modern standards, that would be fantastic. On top of that, if you're going to move to modern standard, the data is sometimes quite incomplete. We've run into issues before where data is manually published at National Grid or Elexon, and if someone isn't around or it's a public holiday, the data doesn't get published that day until there's people in the office the next day. I'm like, okay, well, why? There's a lot of manual processes that should be automated, and we've had chats with various bodies and they're aware of it and the things are in the roadmap. But I also remember talking to someone 4 years ago and the same things were in the roadmap to fix up. So I don't know when it's going to happen, but it's certainly frustrating, especially because if the data is not there and you don't know when the data is going to be there. So here's actually some plots showing when the data was published for different endpoints, a rolling demand and market index. And you can see that there's a fair amount of variability and spikes, especially around 5 a.m. This is UTC time. That represents sometimes when the data is just late for no good reason. This isn't particularly bad. I remember there was a series of times where the day-ahead auction price would be published 6 hours late. And you're like, okay, I'll just get it then in 6 hours. Or incomplete data often causes a lot of finger pointing. On the 23rd of December last year, there was an incident at National Grid where various, it's just a tech incident, some things went down, that's fine, it's understandable. It meant that the data they were publishing for a few hours that day was reporting zeros everywhere. So if you're looking at the data and looking at how much power the nuclear plants were generating, the answer was zero. There was zero power from nuclear, zero from gas, zero from oil, zero from everything apart from solar and wind, which come from different sources. They got that fixed up, but by that point in time, Elexon had digested the data from National Grid, digested the zeros. They don't update this, and so when you reach out to say, hey, Alexa, like the data is wrong. They say, well, no, we got it from National Grid, and the National Grid. I've played this sort of ping pong back and forth, like whose responsibility is it to actually make sure that the data users get served is correct? And the lesson I've learned from this is it's no one's responsibility unless you happen to have good connections within the bodies to make something happen. And the final pain point, to end on a semi-positive note, is that there's no official marketplace to find this data. So if you don't want to go to one of the regulatory bodies, where do you go? The largest one that I've found is called Realto. I don't know if other people know of it or use it, so I put the link in here. I do not personally, I don't have a paid account with them, so all I know is that I've been pointed to this by a few different people, in that it allows you to sort of see various companies or bodies that offer APIs, even though one of the issues here is that it doesn't show you how to connect, and most of these are sort of pay gated as well. So just because it's there doesn't mean it's free to access, and it doesn't mean you know how much it costs until you go through talking to someone about an enterprise agreement or similar. But the fact that this exists is great. This didn't exist a few years ago. So at least we're heading in the right direction, though I wish there was a more official way of doing this that made life easier for our friends in academia that can't just throw cash at problems. Not that I can do that either, but I remember how difficult it was back in the day. Anyway, that is my final pain point. So that's the end of all the things I was going to talk about. I will now, I guess, stop presenting my screen and open it up to any particular questions people have.
Thanks very much, Sam. If you have any questions, please do drop them in the chat and I will kind of pass them on. But to kick us off, I guess you've talked about pain points with publishing and like large organizations publishing. I guess potentially, some of the people on this call might not be part of a large organization, but they might end up publishing data of some kind. You said long format for saving when you're going to use it yourself, but I assume you wouldn't recommend that when publishing, or like if people were going
No, it's even more important when you publish data. So in a wide format data, so imagine your typical pandas data frame, you might have the date that your data was relevant to, so like the settlement period, and then let's say gas price, right? Or wind forecast. You want to know when that data was actually available. So one issue that we had a lot with using papers that came out of academia was that they were using data in their research that wasn't available. So like it's not possible to replicate what they're doing in real time in industry. So as an example, the imbalance price. I remember reading a paper a few months ago that showed that one of the key features, if you're trying to predict the imbalance price in the UK, was the prior imbalance price. And I'm like, I completely agree. But the issue is it takes around 53 minutes for the imbalance price to get published. You have to submit prices, unless you're nib chasing, an hour in advance. So you don't have the previous imbalance price. You have the imbalance price 4 settlement periods ago. But because most data gets saved out in that wide format where you don't have access to when the data was published, that subtlety is lost in a lot of research contexts, where it does need to be taken into account because it completely invalidated the usefulness of that study for me. So if you have long format data, it's very easy to add this in. You have the date that your data was relevant for, so the date start, your key value pair, and then you can put when the data was published, so that you know exactly, as of this time, I would have had access to this amount of data.
That makes sense. Any other questions from people? Do drop them in the chat. Another one from me whilst we are waiting is documentation, and kind of like moaning about documentation. Is there a standard that you're aware of that you're like, go here, and this will tell you what you should include in your documentation, or like how you should format your documentation. Do you have like best practice you want to point people to?
Yeah, so I guess there's two sides to this. There's if you're sort of trying to document code or API, like if you're the person that makes the APIs and you want someone to be able to use them easily, great. And then the other side is if you have data. So if you are on the data side of things, there's obviously quite a few open data standards. There's this open data, right? Like it itself. And then they have various guides that show you like this is how you can properly define what your data is. So rather than just giving someone a CSV, you can say, look, this is what each column means, and these are the valid values or the valid ranges. And it allows you to provide metadata on top of your data, which can be useful. But for a lot of people that are simply consuming data, that's what they want to get rather than to generate themselves. For people that are writing any endpoints, I guess a lot of the documentation can be done for you these days. So for example, if anyone has used Fast API before, so it's a Python framework to well, do a whole bunch of web things, but very commonly used for machine learning or serving endpoints, it will generate the documentation for you. You don't have to do anything. It will use how you've defined the endpoint to automatically come up with the schema and give you examples of what the data looks like. And that's like fantastic. So yeah, so you can either use things that help you lift that burden, or you can look at things like open data or the open API specification, which is you can type that into Google and it'll take you to a GitHub repository. So there's quite a few things you can do. It's just how much time do you want to invest? Because there's no cutoff point, right? You can keep adding documentation as long as you want. The more examples, the more tutorials, the better. But at some point, diminishing returns, right?
And what, in terms of usefulness of documentation, is it, do you feel like the thoroughness of the like detailed documentation of each element is more useful than some good real life examples or kind of like working code that runs it? Or like, do you have
I think
examples
working examples are the best thing that you can do, right? Like, that's what, especially as someone that might be a student or someone just wanting data, if you can go somewhere and copy and paste some code and just change like the dates and get back data that works, that's the dream right there. It's like obviously please like also document the data itself, like especially using time series data. Like for the love of God, please put some time zones in there, because I'm sure I'm not the only one here that's been burned by time zones before, especially in the UK data where it's, half of the year, you're not quite sure whether it is a time zone or not. And then suddenly daylight savings comes and everything starts breaking. So I've played this game before and I wouldn't have to play it if documentation was a little bit better.
Great. We've got a question from Daniel Carr. So can you elaborate on what the biggest barriers are for people to transition into data science from kind of like traditional engineering backgrounds?
Okay, I normally get asked what the biggest barriers are from academics going into data science, but from traditional engineering, I believe it's actually the same thing. So this is a part of the report that Steve and I are writing right now. And this is a known problem. We interviewed a bunch of people and the UK government actually put out a report on this. But the biggest skills gap in people coming into data fields, so data science, data engineering, data analyst positions in the industry, is programming. So in that case, most people coming in have experience in either R or something like Jupyter notebooks, but there's often quite a large gap between code that you might write when you're doing some exploratory data analysis in a notebook to the code that you would want to write if you were trying to productionize an analysis or ship something to a client or bundle something into a software package. So those sort of proper software engineering like skills. And I'm not saying that people need to jump too heavily down into the engineering side of things. The gaps that we identified were even down to, what is Git? Do you know what CI/CD is? What's a unit test? Like those sort of questions for anyone that's trying to get into data science. it may sound like they wouldn't help too much. Like if you want to get into data science, like make sure that you have some like analyst experience, or some machine learning stuff or some statistical models that you can apply to time series data. But especially when we're trying to find candidates, the thing that most of them lack are those foundational software skills that allow us to productionize all of their insights.
And that I would kind of echo that, having kind of worked in a kind of large engineering organization, that trying to get engineers into data science, it is the software development side of coding that like is the hardest work essentially often for them. So Patrick Demars kind of asks, to what extent do you prioritize detecting issues with data ingestion, and how well can that be automated?
Okay, so in terms of automating it, what we currently have is, so I showed you a snapshot of our prefect flows. So those automatically schedule ingestions. If those ingestions fail, and all of them fail, then it alerts us. We have a Slack integration via PagerDuty. So I'll get like a little ping, and that just pops up saying that this flow trying to grab this data failed as of this time. Generally, I do nothing for these. A lot of the data sources we get from Alexon and Naps National Grid, they're flaky. We know that they fail. These are not things that have like 100% or close to 100% uptime. There will be market outages and they just won't work for 6 hours. So a lot of the time you just have to sit back and just hope that the data comes in at some point. And if the data doesn't come in at some point, frankly, we still can't prioritize them too much, because at the end of the day, there's nothing we can do. By the time the data is missing, it's too late. So we need to make sure that a lot of, for example, our forecasting models, our machine learning models, they're built to be robust to missing data. That's how we deal with it. We built in those redundancies by imputing data for as long as we can before the model effectively falls over. Because if the data doesn't end up coming in, you have to play the whole help desk game, and hopefully you'll get the data. But by that point, weeks have passed, and it's not like the data is too useful anymore until you want to, for example, retrain your models.
What about when it's not completely missing, but it's like all zeros, like you talked about? How did you detect that, and like, do you make your models robust to that kind of problem?
That's actually even harder. Like, if you have a NaN in your data, great, because NaNs tend to propagate and ruin everything. Like things will fall over. TensorFlow and PyTorch will just collapse if you throw NaNs in them. But you throw a 0 where you're expecting 1,000, like it's not going to care. So how we actually found that was we have some sort of like automated reports that effectively get run every now and like we have different reports on different schedules that just plot various things. So it's effectively like, here's matplotlib or plotly. This is what the demands have looked like, because we try to determine market conditions that are abnormal, because that's actually one of the areas where you can make the biggest profit. So I don't know if people remember like the imbalance price as an example. I've talked about imbalance a lot. So that was spiking over the winter peak to I think around £4,000 a few times. And as an asset controller, if you're charging on imbalance and the price hits 4,000, you're in hot water. And if you've discharged on imbalance and it's 4,000, you've suddenly made more that half hour than you made the entire month. So being able to detect these unusual market conditions is the thing we spend a lot of time on. It happens to also detect when data goes funky as well. So sort of 2 for 1.
Have you looked at the overall impact on missing data on your like business revenues and forecast accuracy and that kind of thing? Have you kind of quantified that at a macro level to use it in arguments or discussions with data providers?
Not too much. I think the issue there is it's hard to point fingers. So if you have a forecasting model that takes in data from a dozen different sources, each of those sources is more like one might be more reliable than the other. But even though you could say, look, how much better would things have been if I had perfect data? That's easy to do, like the perfect data check. It's harder to say, well, look, okay, well, what if it was just National Grid? What if they published everything on time automatically, no delays over the weekend anymore? Well, it's hard to then break down the impact that exactly that one change would have. So for us, it hasn't been worth it. The business case hasn't been there to do that analysis, because even if we found out that it was, causing a good amount of revenue loss, we don't have the means to change it. Sort of these regulatory bodies change when policy changes, when the regulations change, not when I send them an email. As much as I would like that to be different.
Great. Keep the questions coming if anyone has any more questions. But another one, I guess, for me is how do you cope with, or have you got to the stage yet where you've had to be changing the tooling that you've used for these like data pipelines because you were using old tooling and now there's better tooling available? Kind of like, how do you manage that life cycle of the data tooling?
Yeah, so I guess we're in the process of doing this right now. So we're using Prefect 1. Prefect 2 is in tech preview mode. So beta 5 just came out. It's got some good changes. So when it gets released and after they've ironed out the bugs, we'll move to that. So we've started developing already the sort of like the replacement. But because we're doing things up in the cloud, it's easy for us to do them both at the same time. So we'll be able to have one instance running one and one instance running the other. They'll both be sending data to the same place, but because the data is the same, that shouldn't have any negative repercussions. And the data is set to, not override. So we'll be able to detect by comparing the two if there's any difference. But because all the data goes into our own database first, even if we swap out the back end, it won't have any impact on the front end researchers that talk to the database, talk to our feature store and request the data. So by breaking it down into these chunks, there's no sort of, there's no single thing that we can do apart from removing the top level chunk that would stop our researchers being able to access the data. So long as that feature store interface is there, even if the data is late or missing, they can still use it.
Yeah, that makes sense. Robbie Old is joining in with what's your opinion of the National Grid data portal? Isn't it rubbish?
It's incredibly rubbish. The challenging part with this talk was trying to make sure that the pain points were less than half the time. I could have spent the whole time complaining about that, but yes, and I've talked to people that have worked for National Grid in the past, people that were aware of the problems, have joined the company. They're going to fix it from within, and then have left the company years later with effectively nothing happening because it's so slow to move. And I've heard that there's a ton of talented engineers that want to fix these problems, but getting the buy-in from more senior executives, it has been their downfall, because I guess not everyone values data as much as us. But yes, horrible.
Okay, last one, I think, which is in terms of for people who are kind of looking to be building products that are really based on like large quantities of data from the industry. What's your typical split of effort across the organization between people or like amount of effort spent getting the data pipeline set up versus the kind of like end consumers of the data? What's the effort split?
I would say around 95% more consuming the data. So, I joined Arenco. We were using CSVs on Dropbox at this time. We had done that manual curl process. And then I hooked up a few things. Getting the MVP up and running only took about a week. Prefect is it's something that someone else has already built. So we're using established tools that already exist. And writing a few code wrappers is painful, but it doesn't take that long once you have the structure down. So once we put that initial bit of effort in, so it took me around a month until it was completely functional and people were using it. And then it's set up so that it doesn't require maintenance. Like the data flows and all of that happens by itself. I only get notified when something goes drastically, horribly wrong. And like I said before, most of my job then is if something goes wrong to just sit and see if it comes back, because like if the data's not there, I can't make it get there. I just have to wait and hope. So yeah, it's hopefully smooth sailing for everyone using the data from here on out.
Great, thanks very much, Sam. We really appreciate your time and your insight. Thanks, everybody. This session has been recorded, so will be up on YouTube shortly. But do carry on coming to the Value in Energy Data sessions. Thank you, everybody.
Thanks, guys.